Welcome to the KTA Video Learning Series. This instructional series boils down the coatings inspection process, inspection instrument use, and relevant industry standards into brief segments that are easy to follow and understand. You can find the entire list of current and future videos at ktauniversity.com. Surface profile refers to the texture created on a metallic surface by abrasive blast cleaning and by some power tool cleaning methods. The adhesion of the coating system to the underlying surface is greatly enhanced by generating a surface profile in the steel. That is why project specifications often require you to not only clean the surface, but to roughen it as well. Surface profile is defined as the maximum peak to valley depth that is created during surface preparation. Surface profile is also referred to as anchor pattern or tooth. When surface profile is observed underneath high magnification, it appears as a mountain range or a series of peaks and valleys in the surface of the steel. The peaks and valleys created using grit or slag abrasives are generally sharp or angular, whereas the profile created using shot abrasives is more rounded. Surface profile is quantified by measuring the depth of the valleys in relationship to the tops of the peaks. While an inadequate surface profile depth may not properly anchor the coating system and disbonding may occur, an excessive surface profile may cause rogue or unusual peaks to protrude above the coating film, causing pinpoint rusting and accelerated corrosion. Therefore, accurately assessing the surface profile depth for compliance with the project specification is paramount to the successful coating project. Factors affecting the depth of the surface profile for abrasive blast cleaning include the type, hardness, and size of the abrasive media employed, as well as the hardness of the surface being prepared. Lesser factors include the distance from the blast nozzle to the surface and the angle at which the operator holds the nozzle to the surface. Adjusting to changes in profile depth requirements and specifications is best achieved by selecting a different sized abrasive. For projects requiring a relatively shallow surface profile depth, a smaller abrasive should be selected. For projects requiring a relatively deep surface profile, a larger abrasive should be selected, but may be blended with a smaller abrasive to increase productivity. For power tool cleaning, the type of tool and the configuration of the impactors will oftentimes dictate the depth of the surface profile. There are a variety of methods for measuring surface profile depth. For the greatest accuracy, the steel surface can be examined beneath a digital microscope and the surface profile depth measured in cross-section. However, this is not practical to do in a shop or in the field. There are three methods that are practical and routinely used on the shop floor and in the field for quantifying the depth of the surface profile. ASTM D4417 describes three of these methods and includes Method A, Visual Surface Profile Comparator, Method B, the Surface Profile Depth Gauge, and Method C, Replica Tape. The number of readings to determine the average surface profile at each location is based on the number required by ASTM D4417. The average of the readings at each location is the location average. For the visual comparator method, ASTM states that a sufficient number of measurements should be obtained in each area. For the depth micrometer method, ASTM requires 10 measurements in each area, and for the replica tape method, ASTM requires 3 measurements in each area. The ASTM standard indicates the number of readings to take in each area for each of these methods, but does not indicate the number of areas to measure on a structure and does not address the tolerance of the area measurements. As a result, SSPC published PA17, which describes a procedure for determining compliance with the specified profile ranges on a steel substrate in any of these three methods described by ASTM D4417. SSPC PA17 sets requirements for evaluating the preparation process, obtaining surface profile readings, and determining if the profile of an evaluated area is within the specified range. For each specific surface preparation apparatus used during each work shift or 12-hour period, whichever is shorter, you are required to select a minimum of 3 6-inch by 6-inch locations in which to take readings. The standard defines apparatus as an individual blast pot which may supply multiple nozzles, individual self-contained abrasive recycling or blast cleaning units which may contain multiple pots, individual stationary or mobile centrifugal cleaning units, or an individual power tool. That's all there is to it. Log on to ktauniversity.com for other instructional videos on surface profile and other subjects.